Alright, Marco, this is how you do it. This slide is where we started. It tells us what we're going to be doing. Next slide. Assume 100 grams of a substance and express the mass of each element in grams. Okay, so they're going to be in each problem, there's going to be percentages of different elements in a substance. And those percentages are basically the grams. You drop the percentage and you just put grams next to it. Alright, then you're going to convert them into moles, the grams into moles, and then you divide each by the smallest number of moles that you found. If the numbers are whole numbers, use them as the new subscripts and write the empirical formula. If they're not whole numbers, multiply them by a factor to make them whole numbers, and then use them as the subscripts in the empirical formula. You'll see it right now. Bam! Here's an example of what he gave us. First, you're gonna look at these. See, they're all percentages, right? You're gonna make them grams by doing it like this. 44.66 grams. Oops, 0.66 grams. Next one, 18.13 grams. 36.63 grams. 0.5785 grams. Alright, you see how I just put them into grams? Next, you're gonna convert them into moles. You know how to convert them into moles? I think you divide it by the molar mass or something. And then, so you're gonna do like this thing, 1 mole. And then for potassium, it's 39 grams. And that will equal like 1.1. So you do that for every single one of these. So let me just speed it up. Now just put moles. This one is 2.3 moles. This one is 0.6 moles, like also. This is moles too. Moles. Alright, so you get these moles, right? Now you look at all of them. 1.1, 0.6, 2.3, 0.6, and you look at the lowest one. Which is the lowest one? 0.6, right? So you're going to divide each one by 0.6. So 1.1 divided by 0.6, 0.6 divided by 0.6, 2.3 divided by 0.6, and then 0.6 divided by 0.6. So to speed that up, I already divided it. This one is 1.8, but then he rounded it to 2. This one is 1, obviously. This one is 1, obviously. And then this one is 1. No, this isn't 1. Crap. This one is 4. No, 3.8. But then he rounded it to 4. So, okay, now you look at these new numbers that you got. The number 2, and number 1, and then number 4, and then number 1 again. And those are the new subscripts of the empirical formula you make. So the answer to this problem is K. You see how this was the K one? And then 2 is the subscript. P, subscript of 1. O, subscript of 4. And then H, subscript of 1. And then this is your EF, empirical formula. You got it? Tight. And then he gives us another example of that, and then of 1 that's not whole numbers. See how these numbers are, you see how these numbers ended up to be whole numbers? In the next example, I'll show you where they're not whole numbers. Hold on. Alright, Marco, here's another example, but this is the one where this applies. If not whole numbers, multiply by a factor to convert to whole numbers, and then use them as the subscripts for the empirical formula. Alright, I'll just go over the steps again, just in case if I wasn't clear. So here's the problem that we get. Now, you just drop the percent and then just put the grams. See, 40.92 grams, 4.58 grams, 54.50 grams, and then you convert them into moles. These are moles right here. MOL. These are moles. Alright, you see how we just converted the grams to moles? And then you get the lowest one, and you divide that by each of them. So the lowest one of these three moles are 3.4. So 3.4 divided by 3.4 is 1. 4.6 divided by 3.4 is 1.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333. Alright, so this is where they're not whole numbers. See this 1.33? You can't just write the subscript as 1.3 and then like a line saying that's going infinite, right? So what you gotta do is you gotta multiply it by a number to make it a whole number. And then, so he chose 3, which he used 3, and then that equaled a number that's pretty close to 4. So he used 4. So again, to write our empirical formula, it's C subscript of 1, H subscript of 4, C 4, and then oxygen subscript of 1, and then that's your empirical formula, and that's it. Alright, next one. This is a pretty easier one. See, 46.14 of carbon, 53.8 of nitrogen, 46.14 grams. Convert them to moles and then round it. Same thing for nitrogen. 4. See, 4 out of 4, 4 out of 4, 1, 1, and then those numbers become the subscripts. See, like this is C1, N1. Yeah. Alright, Marco, this is for the molecular formula. The true formula containing the total number of atoms in each element present in one molecule of a compound. Alright, so this one is like an extension. It's like the same thing as the problems I just did, but then it's like an extension, basically. So here's an example. This is the problem, and see, I already converted it to moles. So, 40 grams, convert to moles. This 6.716 grams into moles, 0.5329 into moles, and then you write the empirical formula. But then you see how we simplified it? It's CH2O, because I guess if it was C3H6O3, you can divide it all by 3, and then you'll get CH2O. So what you're gonna do is you're going to find the molar mass of the empirical formula now. So to find the molar mass of the empirical formula, you're going to add. So you got like 1 carbon, see, 1 carbon, you got 2 hydrogens, and then you got like 1 oxygen, right? So this will equal, hold on, yeah, so you just add the molar masses. So this is 12 grams because carbon weighs 12 or whatever, hydrogen weighs 2, and oxygen weighs 16. Alright, so you get these numbers and you add them. That's 30 grams. Alright, and then it's going to tell you what the true molar mass of the substance is. So for this problem, the true molar mass is 180 grams per mole, right? Alright, and then you're going to get this, you're going to plug it into this formula. Hold up, let me make some more space. Bam. Alright, you're going to plug it into this formula right here. It's actual molar mass divided by the empirical formula molar mass. Alright, and then it's going to equal a whole number. It has to equal a whole number. Otherwise, I think might have done something wrong, right? So for this problem, you're going to get the actual, the one that they gave us. So that's 180. Divide that by 30, the one that we calculated, by the empirical formula, and that equals 6. Now you get this number, 6, and then you go to this, the empirical formula that you found in the very beginning, and you get that number and you divide and you multiply it by the subscript of the empirical formula. You got that? So the subscript of this carbon is 1. So like 1 times 6 is 6. So it's C6. And then 6 times 2 is 12. So 8 hydrogen will have a subscript of 12. And then for O, it's 1, right? So 1 times 6 is 6 again. And then that's it. This is your answer for the molecular formula. Alright, Marco, this is another example of the molecular mass. So starting on the left side here, this is our problem it gave us. And as always, you would change them into grams, so 5.9 grams, and then you convert into moles. And then C94.1, you make that into grams, and then you convert it into moles. So we got these two numbers, and then we just rounded off to 6 right here. And then we wrote our empirical formula, and it was OH, because originally it would be O6H6, but then you can reduce it into this, OH. Alright, next step, you're going to find the you're supposed to find the molar mass of the empirical formula, and you do that by, like getting the molar mass of each element. So oxygen is weighing 16 and hydrogen weighs 1. So you add those and then you get 17 right there. Alright, then you get into, on the right side, you go on to this formula, actual molar mass over the empirical formula molar mass. And see right here in the problem, it already gave us the molecular weight, which is 34. So you got the actual, the one that they gave us right over here, 34. And then the empirical formula one that we calculated, which is 17, right there. And then you get the number 2. And then you go to your empirical formula that you found in the very beginning and put it right over here. And then you multiply it by 2 because that's the number you plugged into the formula, and then you get O2H2, and then that is your answer. So yeah, that's the best I can explain it. If you have any questions, just give me a call or I'll talk to you tomorrow.